Okay, actually, I'll come back to this in a second. Before we get started, though, I don't know if you noticed on the Google Classroom yesterday after class, I put a video here. This is a tutorial on a Google Chrome extension called Equatio. I think that's how you pronounce it. It's equation without the N at the end. And it's actually a pretty cool application. It's a long video, it tells you how to install it and then goes through some basic stuff. But towards the end here, okay, it shows you that we can actually use this on Google Forms. So if in Google Forms, I ask you to type an equation, and sometimes I have, and it's difficult because we're dealing with fractions or we're dealing with squares. And then later on in the year, we'll be dealing with something called limits. That's hard to type in Google Forms, and I understand that, and that's why I usually give you guys an option to submit a picture. But with this app, with this extension, you can literally draw in what you want to, and it'll give you, let me see, yeah, there we go. So you can draw in and handwrite what you want, and it'll give you the mathematical representation. And then you can even, once you're done, as you can see here, are they going to be done? Almost. You can copy and paste whatever you typed right into the Google Forms. All right. So I think it's really cool. It's a 16-minute video, and like I said, the beginning is just telling you how to install it. I think you guys are pretty tech savvy and can figure out how to download a Chrome extension. And again, the beginning part is just basic stuff like fractions, but then about, the 9-minute mark, they start talking about equations and stuff like that. So I'm not making this mandatory. You don't have to download this. I don't know if you're allowed to if you have a school Chromebook. I don't know if they let you, download stuff. But it's something to take a look into. And, for AP Calculus next year, it's definitely going to help. So I just wanted to show that to you, make you aware of it. And, I'm a bit of a nerd, so I thought that was cool. So use it or don't. It's up to you. Like I said, I'm not making it mandatory. But I would recommend it. It makes things a little easier. And there's also some other things that you can look up to do on it. Okay, that aside. Today we are starting the last section of trig rules and formulas that we can use. Now the ones that we're going to go over today and probably tomorrow, I don't think we're going to get through them all today, are a little less common. You're not going to see them as much. And, especially outside of trigonometry, obviously they're useless, but they're good to know. If you plan on going into any science where you use trigonometry, like I said yesterday, anything with audio, anything with visuals, where you're dealing with waves, sound waves, things like that, you're going to be using trigonometry. Okay, so audio engineering, right? For those of you who are vocal majors, things like the acoustics of a room. You can figure out where the best spot to sing is to get your voice projected, to amplify that. You can figure out where to place speakers in order to get the best sound in the room. There's a lot of cool applications for trigonometry. So some of these are called multiple angle formulas. Some of them have different names, and we'll be going through some of these rules. Now, these rules only apply to sine, tangent, and cosine, sine, cosine, and tangent. We don't have special rules for cosecant, secant, and cotangent, so we will be just focusing on our three main trig functions for the remainder. So first here we have double angle formulas. Now, we utilize these rules, usually when we're trying to solve an equation that may be difficult to go through our normal algebraic steps. All right, so we have the three rules here we actually get from our addition rule. Okay, so for the first one I'll show you, and for the second and third it kind of just follows suit. So for sine of 2u, that's like saying, I'm going to put it over here, sine of u plus u, which we just learned, which would be sine of u cosine u plus cosine u sine u. Right? Normally we would swap, but because everything's the same, I'm adding u twice, right? That's what 2u is u plus u. I can reduce that to 2 times sine u times cosine u, because we have that twice. Okay, so sine of 2u, if for some reason you didn't have a calculator or you needed to expand it, right? If you don't want to deal with the double angle inside, you can make it 2 times sine u times cosine u. Okay, and the others we also get from our angle addition, but I'm not going to bore you with those proofs. But for tangent, okay, we have 2 tangent u over 1 minus tangent squared u. And then for our cosine, this one's actually interesting. Actually, I'll put this here because cosine of u plus u gets us cosine u plus sine u sine u. So that gives us cosine squared u. Oh, minus, my mistake. That should be minus sine squared u. Now, with this, I can come up with 2 others using the Pythagorean identity. All right, so for this one, I replace sine squared u with 1 minus cosine squared u. And for this one, I do the opposite. I replace the cosine squared u. So all of these are equivalent statements. Okay, if I typed each one of these into a graphing calculator or a graphing app, they would all give me the same graph. All right, and again, I'm not expecting you to memorize these. I mean, these, like I said, they stem from our angle addition that we just took a look at. So you might be able to kind of connect the dots there. But anytime that we're dealing with this, okay, I'll allow you a cheat sheet or a reference sheet where you can write down the formulas so you don't have to memorize them all. Especially by the end of this lesson, by the end of tomorrow, we're going to have quite a few more rules. All right, so let's take a look at an example. So like I said, most of the time that we're dealing with these, we are going to be solving. Right? We're going to implement these to solve to kind of help us along. So for this example here, we have 2 cosine x plus sine 2x equals 0. Now, if it was just, maybe 2 plus sine 2x equals 0, we could use our normal algebra. I can subtract 2, I can take the inverse sine, and then whatever I get, I would divide by 2. Okay, and I think we saw an example like that yesterday. Give me a second, let me see. Or recently we saw something like that. Yeah, so when we solved for multiple angles, this might have been last week, right? We took care of this at the end. I waited until the end and I divided everything by 3. Basic algebra steps, right? Solving an equation. Oops. But here, our problem is I don't just have the sine of 2x. I also have a cosine x. So that kind of makes things a little more difficult to separate. Okay, I can't get my x's alone because this one is tied up with a cosine, and this one's tied up with a sine and this too. All right, so I'll put a parentheses around that. right? So if we see a situation like this where we're dealing with more than one trig function and one of them is this double angle form, then we're going to use our double angle formulas to simplify. Okay, it's kind of like using our identities from, our previous lesson. And then that allows us to solve. So here, the first thing that we would do is I would replace this sine of 2x. Okay, and I'm just going to replace it with what I see up here. So this, at first, I still have the 2 cosine x. That's not going to change. We're not touching that. Plus, the sine 2 of x is going to become 2 sine x. I should probably look where I'm writing. 2 sine x cosine x. All right, and then it still equals 0. We didn't touch that yet. So now you're saying, well, we just made it a little not a little more difficult, but it may look a little more difficult because instead of just having a cosine and a sine, now I have a cosine and then another sine and cosine. But I can drop these parentheses. I just put them there just to show that that's our replacement. And then we can kind of treat this like we normally do. So looking at this, again, I can't solve this right away. I can't just subtract because that would put a variable on the right side, and that goes against what we want. We want all the variables on one side. So we look for something that's shared in between these two terms because we're adding them. So both of them have a factor of 2. So I pull out the 2, and they both have a cosine. So I pull that out. When I factor out a 2 cosine from here, I'm left with 1. When I factor out a 2 cosine there, I'm left with sine of x. And now we have a basic multiplicative property of 0. Okay, I'm multiplying two things together and it equals 0. So that means the first part is 0 or the second part is 0. Oh, I forgot to put. So we're only looking at from 0 to 2 pi. Right, so we go about and solve. Well, 2, I can divide both sides by 2, and I just end up with cosine of x equals 0. So for that, we get (90° and 270 degrees, or because we're dealing with radians, pi over 2 and 3 pi over 2. And then here, again, we just go through the basic steps. Sine of x equals -1. All right, so luckily, these were a little easier. Okay, but let me just bring up the unit circle just to show you as well. So I'm not just throwing out answers there. I should probably save this somewhere instead of just finding it every time. So again, first I was looking for where cosine of x equals 0. So I'm looking for x values that are 0, which was up here at pi over 2, and then down here at 3 pi over 2. And now I'm looking where sine of x equals -1. So where's my y value equal to -1? Well, that's also down here at 3 pi over 2. All right, so they actually share a solution, and that kind of comes from the fact that we originally dealt with a double angle formula. All right, so your final answers, you wouldn't have to write that twice. Your final answers would be pi over 2 and 3 pi over 2. All right, any questions there? All right, so I'm going to give you one of these to try, something similar to this. All right, so you're going to be using the double angle formula to solve. But in the meantime, here are two other sets of rules. I'll give you some time to copy them down. I know there's, it's a lot of writing. If you're confused, sorry if it's sloppy. They're all U's. So the first we have is the power reducing formula. And this we use if we don't want to deal with squared trig functions. Okay, now we know how to deal with normal squared trig functions, right? If I just had to solve it normally. But again, if there's a situation where I need to break something down because things aren't matching or I don't have, a proper equation set up, I can use these substitutions. Now notice for this, we all reduce them to cosine of 2u. So with this, I'm not a huge fan of these because we're going from a trig function with a power to a double angle, which means we might have to go back and then use the rules that we just learned. Okay, here for the cosine 2u. But usually for these, what they'll do is they'll ask you to rewrite an equation, and we'll see. Maybe I'll get through an example of that. And then over here, we have what's called a half angle formula, which means that we're dividing by 2. All right, so inside here, the sine of u divided by 2, or 1/2 of u, cosine of 1/2 of u, tangent of 1/2 of u. Again, these, through a combination of the power reducing and our angle addition and our multiple angle formulas, they deal with just cosine. Now also notice in front of both of these, because we have a square root, we have a plus or minus. So that kind of throws an extra bit of information in there. And then for tangent of u over 2, we actually get rid of the square root because of the properties of tangent, how it's sine over cosine. So I would be putting these two over each other and simplifying. And we'd end up with 1 minus cosine u over sine u. And then we actually showed way back when we first started all this, through our trig identities, that 1 minus cosine over sine is equal to sine over 1 plus cosine. All right, so I'll give you another moment to finish copying anything down here. I know it's a bit much, but like I said, these aren't. I mean, I don't want to say that they're not important. Obviously, everything that we're learning is important, but these aren't things that you're going to be using frequently. So I'm just trying to get through them. All right, so tomorrow we'll take a look more at the half angle formula. I'll go over an example of that. But to wrap up today, we're going to use the power reducing formula. So like I said, normally we're going to use this to kind of simplify things. We don't necessarily always use it for solving because we still end up with more stuff. So that would give us an extra step. So what I'm going to do here is I'm going to rewrite sine to the 4th power of x in terms of first power. So I don't want any exponents anymore. So the first thing that I can do is I can say that sine 4x is the same thing as sine squared x squared, right? When we raise a power to a power, we multiply those together to get that power of 4. So here I see the sine squared x, so I'm going to use my power reducing formula. Okay, so I just substituted in with the rule there. So now, unfortunately, we got to do, I'm going to rewrite this. Okay, what I'm going to do is I'm going to distribute this 2 to both of those. So I'm just going to rewrite it here like this. Now be careful. You cannot eliminate those 2's. If there's a 2 on the outside, then you can factor them out and that gives you 1. But this 2 is tied up with the cosine. Okay, so we'd have to get rid of the cosine first before we can get rid of the 2. So this, it's a pain, but we're going to have to FOIL. Right, so first, outer, inner, last. Right, be careful. Do not distribute the squared. That's a common mistake. You know, I see it all the time. Don't do that. I wish that was the way you could do it, but it is not. So once we do that, okay, I'll shorten it for you. We'll get 1/4 minus 1/2 cosine of 2x plus 1/4 cosine squared of 2x. All right, so that's, you know, again, I multiplied the first 1/2 and 1/2 is 1/4. Then the outside and the inside get us the 1/2 cosine of 2x. And then, oh wait, hold on. That'll get us 1/4. This one, yeah, 1/2. And then we have that there. So this, I can make it a little nicer. I can pull out a 1/4. Oh wait, no, I'm sorry. Well, yeah, I pull out a 1/4, but then here, okay, again, I have the cosine squared of 2x. Okay, so I'm going to use this rule, and that's going to be 1 plus cosine. Now, because this is a 2x, and I have to multiply that by 2, that's going to be 4x all over 2. All right, so I did 2 things here. I pulled out the 1/4, so I just had the cosine squared of 2x, and then the cosine squared of 2x I replaced with the power reduction formula. Now from here, it's just simplification. That's weird. I don't know why I did that earlier. Okay, so yeah, I redistributed the 1/4, and yeah, okay. So I'm going to have 1/4 again, minus 1/2 cosine of 2x. And then here I can split this up into 1/2. So 1/2 times 1/4 gives me 1/8. And I have cosine of 4x over 2 times 1/4. So that's going to give me 1/8 cosine of 4x. And our final answer will be 3/8 from the 1/4 and the 1/8. minus 1/2 cosine of 2x plus 1/8 cosine of 4x. So yeah, it's a lot, and I see how it might be confusing. And I just realized I never typed out my objective. Cool.
I really thought that this is gonna be a simple little problem, like yay, you know, and then no.
I'm not gonna ask you to do this. I just wanted to show it to you. I want you to try one of these tonight. I'm gonna give you a problem like that. Don't worry about doing this. Oh, and I didn't even spell discover right. I spelled discover. I'm batting 1,000 today. All right, guys. So keep an eye on. I'll put up. It'll just be one problem with the double angle. Okay, I'm not gonna ask you to do anything with the power rule. Tomorrow we'll do a half angle formula, and we got a few more formulas to get through. They're interesting. And then that's it for the rules. So yeah, hopefully by the end of tomorrow we're done with the rules, and then after that it's all applications. So how we actually use trigonometry. Oh, and the sine. Oh, that's what I meant to ask you. Did you guys ever cover the law of sines or the law of cosines? Did you do that in geometry?
Oh.
Algebra.
No.
No, it doesn't. Okay, that's fine. All right, guys. I kept you too long. Apologize to your next teacher. You can blame it on me. Have a good day. I'll see everybody tomorrow.